Okay, so composite shapes. We started composite shapes the other day. Composite shape just means like two things that are basic shapes that we know stuck together. This is a composite shape because we have this circular shape up top, and then we have this thing right there, another cylinder there. When we're calculating the surface area of a basic shape, it's pretty straightforward. You just calculate the surface area of every side you can see. When you're doing the surface area of a composite shape, you have to think a little bit about overlap areas, what you really need to calculate, and so on and so forth. For this shape, I'm going to break it down into two different sections. The first section that I'm going to calculate is this one right here. I'm going to try to calculate the surface area of that top cylinder. That is a cylinder. It just doesn't really look like one. The reason it is a cylinder is because it's got a circle on the top and the bottom. Most cylinders we see are more like this water bottle, right? Where they're kind of long. This is like a cylinder that's just been really squished down. Right? It's like a pop can that's been squished. That's what we're looking at right now. Yeah, Joe. Yeah, exactly. Like a tuna can. Right? That's exactly what that's like. It's a cylinder still. It's just squished down.
Or pizza box.
Yeah, if it was cylinder. When doing this, calculating a cylinder, there's two different regions that you have to calculate. It's the circles, so the top and the bottom, and then the round part. I'm going to start with the round part. When we unfold a cylinder, what does that round part, the label, end up looking like?
A strip.
A strip, which we would call
A rectangle.
a rectangle, right? So if I look at this guy and I want to calculate the label area, this outside, it ends up making a rectangle when you unfold it. So we just need to do length times width. The length, or the width, depending on how you want to look at it, one of them is really easy. It's just like the height of the cylinder. We're going to call this the label area for the top. So I'm going to have 2 times. Now, the other side of that rectangle, when you unfold it, is a little bit harder to picture. We call it the circumference. It's the area around the top of the circle. Does anybody remember how to find the area around the top of this cylinder? Joe?
Radius times pi times or square.
Close. I think you're thinking of area, which is pi r squared. Rachel?
Pi times r times 2.
Yeah. Pi times r times 2. Yours was pi r squared. That would be the area of the circle, which we are going to use. So you're going to want to remember that. We're going to want that for the next plot. But when we're doing the label, that around the outside edge, you're doing the height of it, which was 2, which I did in blue. And then you're timesing the circumference of the circle, like how far around the outside is. Some of you might have that formula in your notes already. We did it earlier. And we just called it like height times 2 times pi times r, or we did height times pi times diameter, right? So you might see different formulas for that. But they all break down to the same idea, which is the height of that can times the circumference of the circle. Awesome. Your radius. For this top cylinder, what is your radius?
5.
Yeah, it's 5. On the top, they've given you 10, but that 10 distance is all the way across. That's the diameter all the way across. The radius is half of that, which would be 5. So our equation that we need to put into our calculator is 2 times pi times 5 times 2. And that will tell us the area of the label of that top cylinder, the one that kind of looks like a tuna can. If you put that in your calculator, you're going to get 62 points.
It's 19.
8318537. Awesome. That's the area of the outside part of that tuna can thing on the top. Awesome. The next area that we're going to want to calculate is the circular top. Right? You're going to want to get this area up here. I'm going to highlight it in red. It's like the top of the can. It's that circle we have up there. When we do that, I'm going to call it the top. And the top and the bottom are the same, right? They would be the exact same shape. So the top and the bottom of that can. What would the area of just the top be? I've scribbled it out. The area of it. You got the diameter, which is 10. They've given you that. But if I wanted to figure out the area of a circle, what is it, Mark?
Don't you have to do pi times 5 times 2? Pi r squared.
Pi r squared. Yeah. So, and I see where you're going with the 5 and the 2. I see what you're talking about. So the r is 5. Right? He's just putting numbers in. So the formula would be pi r squared, where radius is 5. That's halfway, right? From the edge of the circle to the middle of the circle. Awesome. That would be the area of just the top. The bottom is the exact same. So if you have two areas that are the same, what can we do? We can times it by 2. So this part represents the top circle. Because it's the exact same as the bottom, we're going to times it by 2. Awesome. R is 5, which is what Merrick was saying. So we have pi times 5 squared times 2. If you put that in your calculator, you get 157.0796, and then I run out of space, but it goes 327. You now have the area of the label of the tuna can and the tops and the bottoms of the tuna can. Perfect. Before we move on, we're going to talk about the bottom part of that tuna can, because that bottom part of the tuna can had some overlap, right? It had that longer cylinder that was against it. And technically, we shouldn't be calculating that surface area if there's something against it and it's an overlap region. So technically, we should be subtracting away that overlap. However, I'm not going to subtract it away. Instead, what I'm going to do is I'm going to realize that that area of overlap is the same as this area right here, the bottom of that circle. And I'm just going to not calculate that part, because I know that calculation is the exact same as the overlap region, which I should have been subtracting away. So instead of adding the bottom circle, I'm just not going to subtract away the overlap at the top of it. And it'll save me a little bit of hassle. Yeah, Mark.
Can you do that with like bulbs?
Yeah, so if you look back, you could do that trick over and over again. So like up here, you could have calculated the area of the whole triangle on top, not subtracted away the box. Just make sure you don't accidentally add that box later on, right? Like this would be the same section in green. So if you, and it just depends on the person. So for like you might vision that and be like, oh, I see, that's the exact same thing. I'm just not going to subtract it away. For other people, they might see that and be like, but you don't have that whole triangle. You need to subtract away. And it just depends on how you view a question. Neither way is wrong. One's maybe a little quicker, but it's just how you see a question. So if you're able to see, hey, the bottom that I'm supposed to calculate on that long cylinder is the same as the overlap, I'm just not going to add it. Cool. Save yourself some work. Awesome. We have a second label that we need to calculate. So we have that longer cylinder. This guy right here in the orange. So we're going to have to calculate that label as well. To calculate that label, you do the height, which is 10, times pi, times r. And this time I'm not going to times by 2 because there's not two of those cylinders that I'm trying to deal with. Oh, sorry. My bad. I was doing the top and the bottom. I am going to multiply by 2 because that's the formula. Yeah, question. Yeah, so if you want to do it that way and do the whole shape and minus the overlap, that's fine. What I'm going to do is I calculate like that whole circle. So this guy up here in red, I'll point to it, this guy. And I doubled it to give me the underneath part. And technically I should have subtracted away the overlap, right? This time I didn't subtract away the overlap. And the reason why is because this spot right here is the exact same as that overlap up there. And I'm just not going to calculate this. So if I never subtract that away, I never have to add that, and it balances out. Otherwise, I would have subtracted and then added the same two spots. Which, if you want to do it that way, that's fine. Like if you just see it that way, which some people do, they do it that way. If you can see that these are identical, that's cool with me. And just don't subtract one.
I do shapes just balance each other.
Yeah, they actually kind of are, right? Because one was the diameter was 10, then they turned that into the height of 10, which is kind of cool. So I want to calculate the label of that longer cylinder. We're doing 10, because that's the height of that long cylinder, times pi, times r, times 2. And that's our formula for doing that round part. For us, the radius of that guy is 1. I've covered it up, so it's hard to see, but it tells you that it's 2 right here. So the diameter is 2. That means the radius is half that, which is 1. We'd have 10 times pi times 1 times 2. You throw that in your calculator, and the area of that round part, 62.83. It's the exact same. 5307. Which is kind of cool. You've now broken that shape down into all of its parts. If you want the total surface area, you add all those numbers together. So my final answer would be 62.83185307 plus 62.83185307 plus 157.0796327. If you times by 2, that's the same deal. If you put those in your calculator and you add them all up, and we'll round to the nearest hundredth, which is the second decimal place, you get 282.74. That would be the area of the composite shape. That's all the way around the outside. You like that double overlap and not calculated? Yeah. Yeah.
Then I get messed up.
Yeah, on what to subtract? Yeah, I understand that. It's up to how you see it. Neither way is wrong. If you do one way, I'm not going to dock you marks. Like you would be 100% right. So if you can see it like that, do it like that. Karen.
So in subtracting it, do you subtract the area from both shapes or just subtract it from one?
Just from the one, and then make sure you add that bottom part of that label. Yeah. Awesome. Next question. We've got this thing. It's like layers of a cake, basically. We're going to surface area. Each square layer is 3 centimeters in height. So they've told us the height of all these shapes. That means this guy right here is 3 centimeters. And they're all 3 centimeters. Every single layer is 3 centimeters high. Our job is to calculate the area of this entire thing. I'm going to start with the bottom layer and then work my way up. Okay? If I wanted to do the bottom layer, I'm going to do the outside edges first. To calculate the outside edge would be something like this rectangle. That's length times width times 4. Why would I times by 4?
Because there's 4.
Yeah, because there's 4 sides. And that would give me all the way around the outside of that bottom layer. Our length is 40. Our width is 3. Our edges are 4. That means all my edges together would be 480. That's my outside edges. Is 480. Length times width, which is height really in this question, times 4, because all 4 edges are the exact same. Yeah. All right. The next part of this layer of cake is to do the bottom and the top, like underneath it. We're going to talk about the underneath part, like under here. If you want to do that, it's length times width times 2. The reason I'm timesing by 2 is because it's top and bottom. There's 2 sides that are the exact same. Now, I understand that that top layer has overlap somewhere. And we're going to talk about that because with this question, it's a little bit weird. But for now, I'm just going to calculate it as if it's not overlapped, and we're going to just discuss how I can handle that situation. So I can do a length times width times 2. My length is 40. My width is also 40. And then I times that by 2. And I get 40 times 40. It says each square layer in the question. So even though it might not look like it, it did define it as a square for us. Because I agree, it doesn't really look like a square, but it does say each square layer. So we know.
Yeah. It only gives you one measurement.
And it gives you one measurement, which usually is safe to assume. They should have technically written it out.
Wait, how's the first one bottoms, then the other one bottoms?
This is the whole bottom layer.
What?
The whole bottom layer of cake.
Okay.
Like-
What's top and bottom?
That means that's the top and the bottom of the bottom layer. So I'm still only like, when I say top and bottom, I mean the underneath right here and the top part of this bottom layer.
Okay, so like the what on top is like the label.
Yeah.
Kind of.
Yeah, for sure. Okay. Let's talk about the overlap because this overlap's a little bit like trippy. When you look at the top, there is overlap that technically we should have subtracted out. That overlap, I'm going to color it in red, what is not overlap. This right here. What is overlap is this section right here that I'm going to color in green. It would be the entire top of this second layer. Except that top layer also has overlap, which would be this entire top. So it's like a double overlap that equals what I should have subtracted off the top layer. But these two green sections, if you added them together, those two green sections together, that would equal the overlap from the top of this bottom layer. It's almost like if you imagine looking straight down on it. It would just look like one nice square, right? Because this would overlap with this, which would be the exact same as the overlap on that. And it adds up to one big square on the top. It's kind of tricky to imagine. I'm going to draw another picture. You don't need to draw this. It's going to be if I look straight down on it. Okay? If I look straight down on it, I would have this. I'm going to color it for you just a second.
It looks like it's going down.
Okay, that's as if I'm looking straight down on it, correct? This red layer is the bottom layer. In that red layer, there's overlap that we should have technically subtracted away. that overlap, visually looking at it in this drawing, is the exact same as if I took this section of the second layer plus this section of the top layer. So if I don't subtract away the overlap, I don't need to calculate the tops of the next two layers because they add up to be that overlap. See how looking straight down on it, you can see that?
Sorry.
You see how it equals out? It's tricky.
No, it doesn't make sense.
No, it's like too hard to envision, hey? Okay, only calculating the tops and the bottom. You still have to do the sides of the next two layers. So you have this middle layer in here, which I'm going to color in blue. You have this right here that you would have to calculate. When you go to calculate the middle sides, you're going to do length times width times 4. The length is 28 times the width, which is 3, times 4 sides. If you put that in your calculator, that will give you the outside edge of the middle layer, which would equal 28 times 3 times 4 is 336. I think I said 36. I was like, oh, it's way bigger than that. 336 is right. Then you need to do the outsides of the top layer. The outsides of the top layer I'm going to highlight in orange. So we're talking about this section up here. You're going to go length times width times 4 because there's 4 sides to that top layer. That's 20 times 3 times 4. Thank you. That's 240. And those top layers are already calculated in my red calculation because they were technically overlap and I don't need to recalculate them because I never subtracted away that overlap. So I don't need to add them. Your final answer to this question would be the bottom layer, which we decided was 480 plus 3200. That's from the bottom. Plus the middle layer, which is another 336. Plus the bottom layer, or the top layer, which is 240. Yep.
4,256.
4256. Sorry, that's a little small. So that's all the areas we calculated added up together.
So 4,256.
Yeah. I tried to zoom in so it's a little bit more clear. That's good. Okay. The next question. This is just like a two-sided cake, basically, like a two-layered cake. We have a cake is in the shape of one small cylinder on top of a larger cylinder. Determine the surface area of the cake that the icing would cover. So sometimes you're not actually calculating the surface area. You're determining the surface area that needs icing. If you were icing a cake, would you ice underneath it?
No.
No, right? It would be delicious, but you wouldn't do that. You would just put the cake down and you layer the icing around the outside and the top. So you don't need to calculate the bottom. Remember that some questions give context. You need to follow that context. For instance, buildings, right? They talk about painting the outside of buildings. You don't paint the bottom layer of a building. It's on the dirt. Same idea with this cake. You don't ice the bottom layer of a cake. Good job.
But like, wouldn't you also do the overlap because that's how it sticks together?
We're going to assume that, yeah, I kind of agree with your thought process there. We're going to assume that maybe like it's in the middle of it. It's like coming out of it. It's one really cool looking cake. Yeah.
Oh, I made a cake like that.
Yeah, it's like they had one big cylinder and they cut out a little circle to create a smaller cylinder, but it's all one cake. There we go. That's what we're going to go with. Okay. 4, 2, 5, 6. 2, 5, 6. If you want to calculate the area that you're icing on this, we'll start with the outside edges because it's probably the easier spot to start. On the bottom layer, you have this outside edge around here that I'm going to color in red. Yes?
We can't see.
Yeah, your picture didn't come out very good. I apologize for that. Like on your, the toner on it was running out. Yeah, it's really bad. I apologize for that. So that outside bottom layer, that's a rectangle if you were to unfold it, which is just length times width. The width is always easy. It's that height of that layer. So we could do that. That's 5. I'm going to label this. So this is the bottom side. Times, you need to do like the circumference of the circle. Our formula for that is what?
Well, for ours, it would be 5 times pi times. Or we go to the bottom.
Yep.
So 13 times 2.
How'd you get that?
Well, you have the diameter, which is 26, so 13. And then the circumference is the formula for circumference is the height of the cylinder times pi times r times 2.
Awesome, you got it. So he's got it right. It's 13 times pi times 2. The reason it's 13 is because 13 is the radius. Radius is half the diameter. So I'm trying to point out with that like little blue arrow, the diameter is 26 all the way across. 26 divided by 2 is 13. Yeah. Oh, if you're using the formula it's just pi times d, which is diameter, that's fine too. So if you don't want to cut it in half, you don't need to. It just depends on the question because sometimes they won't give you the diameter and people have a hard time picturing doubling the radius, but they have an easy time cutting the diameter in half. That's why I tend to use pi r times 2 because it's one that people typically do better with. 26? Yep, 100% you can. So if you like pi times d, which is pi times 26, that works too. It's the exact same. Yeah.
What's which part? R equals what?
26 divided by 2 is what I have written there. 26 being the diameter all the way across, divided by 2 because you're cutting it in half to get a radius. Yeah,
Does that say 5 times pi times 13 times 2?
you got it. So 5 times pi times 13 times 2 should be 408. 0.407045. The next section I'm going to calculate is the top side. This is the top side. To calculate that, again, it's like the height of it, which would be 5, times pi times r, which in this case is 7, times 2. If you just did pi times 14, that's the same thing. Right? 7 times 2 is 14. If you put that in your calculator, you get that the top sides of the cake would be 219.9114858. $219.9114858. 911. The last section that we need to calculate is going to be the big circle on the bottom. The way I would picture doing this is I know that this in green plus this down here would equal the area of the big circle on the bottom, because the overlap that I need to subtract is the exact same as the top of that circle. So all I need to do is the area of the big circle. Don't worry about the overlap. And I should be fine. So I'm doing the big circle. The area is pi times r, which is 13 squared. Just the big circle. Because that section that you would subtract away, like that overlap, is the exact same area as this top that I would add later. So if I just don't add this, then I don't need to subtract away that. Because it balances out.
No, I see that.
Yeah. So now you're just doing the area of the big circle. Yes, sir.
Usually you would do like times 2 on that, but you're not because you're not doing the bottom.
Correct. And I'm not times by 2 because I'm not icing underneath the cake. Just that top layer. Yeah.
What's the formula for the big circle?
Pi r squared. So the area of circle is pi r squared. If you put that in your calculator, you get the area of the circles, should give you 530.9291585. The area of the entire cake is every single thing added up. Yes, sir.
Oh, I see.
Okay. So if I add those numbers, you get your final answer, which I'm going to write on the top, of 1,159.25. I added all these. Killing it. Definitely. All right. No more questions about these overlapping cake questions? They're a little confusing. I wish. The last ones we're going to do